Next, with the understanding of injective or one-to-one functions, we can consider inverses. Suppose a function f is injective or one-to-one with some particular range of f in mind. Then the inverse function of f is this unique mapping f inverse from the range of f back to the domain of f, such that f inverse of f gives back x, or gives back what's given in, or this is called the identity. In other words, f inverse and thus f. Now, given a particular f, how can we find the rule of f inverse? You might have heard the business about swapping x and y, but how does that work? The proper way is, you always start by writing let y inverse equal to f inverse of x. What does that do? Well, think about this. Y inverse, f of y inverse is nothing but f of f inverse of x. Now we note that this is the identity, or just x. Therefore, we can collect the left and right hand side of the equality to get f of y inverse equals to x. So the complete statement often looks like so, that y inverse equal to f inverse of x, such that f of y inverse equals to x. From now on, you can solve algebraically for y inverse, which is subsequently f inverse. Now that we know a formula to find the rule, we also need to think about when does the function f x to y have an inverse? If not, can we restrict it to establish an inverse? In particular, there are two types of functions. F could be injective, or one-to-one, or many-to-one. We note that we must have an injective function in order to solve for f inverse. Whereas if we have a many-to-one function, we can't precisely define f inverse. Why is that? Recall that the horizontal axis is a representation of the domain, the vertical is a representation of the codomain, or y. Now, when you find the inverse, you will be given a value y in the image. And the inverse is supposed to take the value y back to the original value of x. In other words, you should be looking vertically, like so, to get back to original x values, to achieve this concept of an inverse. However, if you now look at many-to-one functions, when we look horizontally on the axis of the image, we see that it doesn't satisfy the horizontal or the vertical line test if we suppose now for y, this direction would be vertical. In particular, the true difficulty of finding a proper inverse for a many-to-one function is that if we are given a particular value of y which we want to find the inverse of, we can't uniquely define the value of x which this value of y came from, so we can't find inverse. But we can modify or restrict this function such that it has an inverse. How to do that? Well, we need to restrict the domain such that it is a one-to-one function. For example, from here to here, or from here to here, but not from here to here. So the answer to the question is, we need to restrict domain such that f is 1 to 1. Importantly,